Welcome to Bite-Sized Data Science. Over the last 6 videos, we've talked about spatial data in the context of geographical data. There is a lot more to learn about the different libraries used, such as GeoPandas and Shapely, and there are more libraries that can be useful. At least, with what we've covered, you're well on your way to mastering this subject. In all the examples we have seen so far, we talked about longitude and latitude. There could be another value added to those for altitude. This means that we can have three-dimensional spatial objects, and, of course, this is useful when dealing with geographical data. For example, the temperature at a specific longitude and latitude would vary based on altitude. Spatial also applies in image recognition. Where is a face located in an image? Where are the different objects detected, and what space are they using? In this example, it can be a simple XY reference system until we get to 3D images. We can easily expand our concepts of geographical data by applying it to a warehouse, for example. Where are the assets or goods located? How can we optimize collecting these goods into a collection order? In this case, our reference system is the warehouse itself, including potentially an altitude attribute that could represent a floor or even a specific shelf. How far can we take spatial data? What about plane design, circuit boards, and so on? By applying buffers around the different components, we can detect if one part interferes with another in the design. This is, in fact, used in computer-aided design and computer-aided manufacturing, or CAD/CAM systems. We live in a spatial world. The same idea of using spatial data in CAD/CAM systems to design planes and automobiles can also be used to figure out how to optimize the packing of a container. We saw that there can be a large amount of spatial data, but maybe only a fraction of it is relevant. With the Census Bureau information, the data was either for the entire United States or divided by state or even by county. This way we can limit the amount of data we need to process. Adding additional attributes to divide the spatial data is one approach. If we have a lot of data, is there a way to index that data based on its spatial characteristics? These indexes are included directly in some persistent storage systems, such as many relational database systems. This way, performance can dramatically be improved by eliminating a lot of spatial objects during retrieval. There are multiple ways to index spatial data. You may have heard of grid indices, quad trees, and octrees. This is basically dividing the space in a grid and map spatial objects to sections of the grid. Arguably, the best spatial index is the R tree or region tree. It is like a B tree but for multiple dimensions. It divides the tree based on the objects added. When searching for a specific space, it navigates down the tree and retrieves the relevant object. Overall, we saw that spatial data cannot be ignored since it is used to map our physical world. This is not just about geography. It can apply to a variety of other areas. Knowing how to manipulate and optimize access to spatial data is an important subject that deserves everyone's attention. See you next time on Bite-Sized Data Science, and don't forget to subscribe.